Hey there, my name is Anthony, and I'm going to teach you how to make the bane of every calculus student's existence, the hyperbolic paraboloid. As you can see here, I've done a little sketch of a hyperbolic paraboloid, and now I'm going to show you how to draw one. Alright, let me just fill in these axes here, x, y, and z, and now we're going to figure this thing out. So the basic formula of a hyperbolic paraboloid is z equals y squared over b squared minus x squared over a squared. We're just going to make this z equals y squared over 4 minus x squared over 4, just to make things simple. Now the key to making one of these things is to have the right guidelines. So we'll set a few variables to 0. So in this case, x equals 0, which will give you z equals y squared over 4, which is just a parabola. And we're just going to make a table here. So the values of -2, 0, 2, the values of z will be 1, 0, 1. So now we're going to draw this parabola. So we're going to have points at 0, 0, 0, I believe 0, 2, 1, yeah, hey, and 0, -2, 1. Now we're just going to do the same thing we did earlier, except for a different variable. So let's do y equals 0 this time. And that will just give you z equals -x squared over 4. And we can just make another table if we want. -1, 0. Alright, so let's just do the same thing again. And it's going to be another parabola. And this time, we're going to have points at 0, 0, 0, 2, 2, 0, -1, and -2, 0, -1. So now for the tricky part. So you're going to want to do this again for z, but at z equals 0, you're going to have 0 equals y squared over 4 minus x squared over 4, which is completely useless to us. So let's take a look at the graph. We're going to want to see how this guideline works with the other guidelines. So why don't we try it at this point, or this plane, z equals -1. So you're going to get -1 equals y squared over 4 minus x squared over 4, or 1 equals x squared over 4 minus y squared over 4. This should look very familiar. It's a hyperbola. Hey! Hyperbolic paraboloid. Eh? So if you're in multivariable calculus, I'm going to assume that you know how to make a hyperbola by this point. So we have a equals 2 and b equals 2. So let's make our box at the plane z equals -1. And let's connect the corners, make our asymptotes. And your major axis is going to be x. There we go. We're almost there. So now you're going to have to find a parabola that will connect your top guideline you see here and your hyperbola at the bottom. And to do that, we'll have to find the variables and plug them in like we did earlier. And so our variables at these 2 points I'm pointing out will be y equals plus minus 2, which will give you the equations z equals 1 minus x squared over 4. So we'll just make another table, which honestly is the same parabola that we made earlier, just pushed up 1. Because x and y are squared in the original equation, this means that no matter if it's positive or negative, it's going to be the same parabolas at these 2 points. Now you'll just see me extending those 2 parabolas down to meet the hyperbola. What I'm doing here is I'm just darkening the lines and making the general shape so that you can see the fruits of our labor. So before I start shading, I'm just gonna make the most common hyperbolic paraboloid we see in our daily lives, which is a Pringle. And cue cheesy elevator music as I shade. there we go, your very own hyperbolic paraboloid.